This is Lesson 6-1B from the Algebra Readiness textbook. Today's learning target is to be able to convert between customary and metric units and also be able to convert unit rates. Throughout today's lesson, we will refer back to this chart. And in this chart, you're able to see some of the customary and metric conversions. These are our conversion factors. So, for example, 1 inch, inches is in customary units, and centimeters is in metric units. 1 inch is 2 54 centimeters. Refer back to this periodically throughout the day. For our first problem, we are going to convert 10 quarts into liters. 10 quarts is a customary unit that we use here in the United States. So we put our first one, following the directions like we did the last time, to convert between just between customary units. We used a method called dimensional analysis, and we're going to go ahead and use that again today. In order to do this, you want to set up the given information as a ratio over 1. I'm given 10 quarts, so 10 quarts over 1. Step 2, multiply by a conversion factor, making sure the undesired units cross off, and then multiply. So this is the conversion factor. 1 quart is 946 thousandths liters. Now I'm going to strategically place this so that my unit quarts will cross off, because I want quarts to go away and I want liters to be left. In order for that to happen, the rule is that a numerator and a denominator can cancel. So I put the quarts there, 1 quart, and I put the liters in the numerator. Quarts are opposite, and they cancel. Then I go ahead and use my calculator, but in this case you don't need to because we're multiplying by 10. And so that just moves the decimal point. 9 46 hundredths, and the only label left is liters. Now, I could write over 1 because 1 times 1 in the denominator, but that would be the same thing. Let's try another one. 14 ounces equals how many grams? So step 1, set up the given information as a ratio over 1. 14 ounces over 1. Multiply by my conversion factor. Now, you're just going to look up in your notes. I'm going to look over here. How many grams and ounces? Oh, here I see one. Now you could also use this one, whichever one you want. So let's use 1 ounce is 28 3/10 grams. 1 ounce, 28 3/10 grams. Notice how I strategically placed ounces so that 1 was in the numerator and 1 was in the denominator. That means that they will cancel out. Then I simply multiply across. And so with that, you can use your calculator, or you can do it longhand. Guessing I don't have many takers on that. 396 2/10. Now, using the other ratio, these are the other conversion factor that I said you could use either. You might have gotten a slightly different answer, but not off by much. These are both approximations, and so they'll have a little variation in their answer. Okay, so pause the video now and work the next 2 problems. Then come back to compare your answers to mine. Okay, for the next one. 14 inches over 1, and then the conversion factor is 2 54 centimeters is 1 inch. Notice how inches are diagonal and they cancel out. Then you simply multiply across and give the label of the only remaining label, which is centimeters. In the last one, 14 gallons over 1, and then the conversion factor that you got from the chart is 3 79 liters is 1 gallon. Notice that gallons are diagonal and they cancel out. The only label left is liters. I multiply across and I get 53 600ths. This is a true story. It's kind of neat. On June 1st of 2019, Mr. Kachera ran 52 8/10 miles. how many kilometers is that? And then it gives me my conversion factor. 1 mile is approximately 1 61/100 kilometers. Do you see how this is written? This is usually what you will get on a test or a quiz. I'll just give you the conversion factor. So we're going to start off by setting up the original number, 52 8/10 miles, as a ratio over 1. I'm going to multiply by my conversion factor, strategically placing my miles so that my miles will cross off by being 1 in the numerator and 1 in the denominator. Then the only spot left is the numerator for 161 kilometers, 1 61/100 kilometers. Then I multiply across. And you get about 85 kilometers. That's a long distance, huh? Okay. Practice is an excellent thing to have on these, so I would like you to pause the video and work these 3 independently, then come back when or continue the video to compare. All right, hopefully you paused it and now you're ready to compare. These are the answers I got. If you need some time to compare your setup to mine, make sure you're pausing the video. All right, now, what if we have a mixed number instead of just a regular fraction? And that's going to happen, and that's okay. Don't be afraid to place that fraction in the numerator of the first ratio. So 3.5 kilograms over 1. So set up the given information as a ratio over 1. Then multiply by your conversion factor, making sure the undesired units cross off. So that means that since kilograms is up here, I need to make sure kilograms is in the denominator. When I look at my chart, I saw that 1 kilogram is equal to 2 2/10 pounds. Then we're ready to multiply across, and you get 7 7/10 pounds. Pause the video, try the next 2. Actually, I think you only have 1 of them on yours. So try the last one of 3.5 liters is how many quarts? Okay. And you should have gotten 3 71/100 quarts. Okay, but that's not all. We're not stopping there. We have more to do than this. The next thing we want to talk about is that a rate, how to convert a rate. Notice this one isn't just converting 10 miles to feet. I'm talking about converting 10 miles per hour to feet per minute. A rate has 2 labels. So to convert a rate, it's going to require you to use 2 conversion factors. The first step is to write your rate as a ratio, 10 miles over 1 hour. See, that's the same as this, isn't it? Now I need to multiply by 1 conversion factor to go from miles to feet. That's this conversion factor. And then I need another conversion factor to go from hours to minutes. So that'll be this conversion factor. And you're just going to multiply all 3 ratios together. So how do I go from miles to feet? Well, I know that there are 5,280 feet in 1 mile. Now I'm going to strategically place the label so that this miles cross off. I want this miles to go away. So that means I need to put it in the denominator. 1 mile. See? The rule follows exactly the same as before. Then 5,280 goes in my numerator. Moving on to hours and minutes. There are 60 minutes in 1 hour. I'm going to strategically place this so that hours, my hours label in the original rate will cancel off. Well, that hours is in the denominator. So this time I need to make sure hours is in the numerator. 1 hour is 60 minutes. Just like that. Now, hours and hours cancel out. Some people get confused, like, how did you jump over to that one from here to there? But remember, the commutative property says that I can multiply in any order I want. So really, I could have switched these two, right? And then they would be side by side. So go ahead and you can absolutely jump across ratios in order to cancel those out. All right, now we're left with feet here and minutes here, which is perfect because that's what we want, feet per minute. Then to calculate this, I simply multiply all of the numerators. 10 times 5,280 times 1 is 52,800 feet. All over 1 times 1 times 60 are in the denominator. And then the label is minutes. I can simplify that by saying 52,800, divided by 60, and go ahead and use that calculator, is 880 feet per 1 minute. Is the same as 10 miles per hour. All right, this takes a little bit of time, but you'll get used to it. Let's try this one. 3.5 quarts per minute is how many gallons per hour? You'll see that over here on the side, I have my conversion factors already listed for me. I start off, step 1, write my given information as a ratio. 3.5 quarts over 1 minute. Notice that this divide bar is where I put the division sign. Okay. Then the next step is to multiply by a conversion factor. One conversion factor for each rate you need to change. So let's start here. I need to go from quarts to gallons. So I'm going to go here and use this conversion factor, 4 quarts in 1 gallon. I see that quarts is right here in the numerator. So that means quarts has to go here in the denominator so that they are opposite or they cancel out. So I'm going to write 4 quarts, 1 gallon. And that cancels out. The next thing we need to do is convert minutes to hours. So that's going to require another conversion factor. So this time we'll use this one. Let's strategically place minutes so that the minutes in the original rate, which are currently in the denominator, will cross out by putting minutes in the numerator over here. 60 minutes over 1 hour. Minutes, minutes. Cross off, cross off. Now I simply multiply across. 3.5 times 60 is 210 over 4 gallons over hours, right? So now 210 divided by 4 is 52 and 5/10 gallons per hour. So think about that. 52.5 gallons for every hour. What if you have a 5,320 gallon pool? How many hours would that take to fill if your hose puts water in this pool at a rate of 52.5 gallons every hour? You would have to take 5,320 gallons and divide it by 52.5. And you get 101 1/3 hours to fill that pool. That's kind of crazy. I've heard those things do take a long time to fill up. I bet some of you have a pool that looks like that at home. All right, next one. Hopefully you're ready to try a couple on your own. Let's try these two. Pause the video, work them independently, then come back to compare your answer to mine. All right, for this first one, you should have set it up as 12 centimeters over 1 second. I need to multiply it by a conversion factor to convert centimeters to meters. I would say that 1 meter is 100 centimeters. I need to make sure that my labels are diagonal so they cancel out. I also need to convert seconds to hours, which requires another conversion factor or another ratio. The other ratio is 3,600 seconds over 1 hour. I chose to put seconds in the top because the seconds is in the bottom in the original, so I have to put them in the opposite spot. Seconds will cross off, centimeters will cross off. Now I'm ready to multiply across. 12 times 1 times 3,600 gives me 43,200, all over 100. When I divide that in my calculator, or just by knowing that these cross off, you get 432 meters per hour. See how you change two rates? All right, the next one. Again, write this out. 8,500 hundredths kilometers per 1 second equals, not equals. Now I want to convert kilometers to meters. So 1,000 meters over 1 kilometer. Again, notice that the kilometers, one is in the numerator, one is in the denominator. That's not the only label I need to switch. I need to convert seconds to minutes. And so I'm going to multiply by another ratio. 60 seconds is 1 minute. Notice again, I placed this just intentionally so that seconds was in the numerator and in the denominator. Now they cancel off. And I'm ready to multiply across. And you get 51,000. 51,000 meters per minute. All right, two more. I'm giving you the conversion factors on the right. Pause the video and try these two. Then come back and compare what you did to what I do. 20 fluid ounces goes in the numerator. 1 minute goes in the denominator. To convert fluid ounces to quarts, I put fluid ounces here so that these cross off. I see that there are 1 fluid ounce is equal to 313 thousandths quarts. Then I need to convert minutes to days. I see minutes is in my denominator, so I will put it in the numerator in my ratio. 1,440 minutes and 1 day. Okay, then I'm ready to cross off minutes and minutes. Now I multiply across. 20 times 313 thousandths times 1,440, and I get 90,000, nope, not 90,000, 9,000 14 4/10 quarts per day. And the last one for today's lesson, 40 miles over 1 hour. Multiply that by 1 mile, 5,280 feet. Being careful to place it so that miles are 1 in the numerator, 1 in the denominator. Then I need to convert hours to seconds. Again, careful so that 1 is in the numerator and 1 is in the denominator. I put hours in the numerator and 3,600 seconds in the denominator. And now I'm ready to cross off my labels and multiply across. 5,280 times 40 is 211,200 feet all over 3,600 seconds. Divide that out because we don't leave it like that. And we get 58 and 2/3 or 6/10, repeating, feet per second. All right, let's give this a try on some independent work. You've got two pages, page 286 and page 289. Ooh, that